logged on early to make sure the Google Drive was going to get caught up, but it didn't. Okay, so how many people presenting today? I will be. Great. All right. Today, Chandler is around.
He had to run, but he has his report up there.
Oh, okay. Is he coming back, or is that just for?
He won't be coming back. I don't think so.
Oh, he won't be coming back. All right. So welcome back, everybody. It's what does that say?
The second.
The 2nd of
September.
September. There we go. That sounds good. Lots to do. I got up too early this morning. We had our meeting with the Germans, but it got canceled at the last minute. We were all in here, and then there was no meeting.
Question. Germans as in German. Wait, did I said the same thing? This
No, I. Yes,
Germans as in
yes.
the Germany or
Yeah.
I know that's
So we were supposed to meet with some representatives from Blickfeld, the company that makes the LiDAR, and they're in Germany. So we just are offhandedly calling them the Germans.
sorry, that was weird.
So I got a lot of like little things, just kind of like bring attention to people. I'm going to do this webinar. So this is LiDAR Slam with the Ouster new LiDAR unit. We don't own this yet, but I'm hoping we'll have it by February. It's a super high resolution scanner. I'm intending to use it for indoor mapping. It's like 128 scan lines. The stuff looks gorgeous. I probably haven't shown very many pictures from this, but anyway, they're doing a webinar on the 14th, which I plan to do. If anybody's interested, let me know, and I'll just do it in here. You guys can just join right in. September 14th at 10 a.m. Pacific.
1 p.m.
Yeah, 1 p.m. our time. We got a request from Tom Crawford, the department chair, to see if Neil wants to be at the CNRE alumni event. So I guess homecoming is on the 15th of October. We did this last year. It was a good time. How many people? Gunjan was there. Just Gunjan? Okay. Andrea Barrett. So it was a nice time. Basically, because we have a lot of fun show and tell type stuff, we make a good person or a good group to go. So we just set up drones and some 3D printed maps and some other fun things like that. So if we want to go, we can. I think it would be a nice thing for us to do, but we need to get some people to commit to being there on the 15th. There's free food, drinks, alumni come around, so it's a good networking opportunity to meet people, but definitely not required. So look at your calendars and let me know how many people think they might be able to go.
I mean, I'll definitely be like going to the game. That's why I'm looking up tonight. Oh, we don't know yet. Never mind.
Okay, if we have this much interest, then I'll go ahead and commit, and we'll just work out the details later. But great. I did a quick review of this paper. So if you're on you can set up Google Scholar alerts and ResearchGate and academia.edu, and when new papers come out, you can get alerts that stuff has come out. So it's a nice way to kind of keep on top of the literature. For people just starting the master's program, this is a good idea to start setting those flags of keywords of things that you're interested in. So this one came across my desk, fast computation of digital terrain model anomalies based on LiDAR for geoglyph detection in the Amazon. This would have been a good one for Colleen, who is doing modeling routes between Incan and Amazonian civilizations. So the question is, where are the Amazonian civilizations? It's pretty hard. Inca stuff we know a lot. It's easier to find. It's relatively recent, but a lot of the Amazonian stuff sort of buried in the forest, people don't really know where it is. And so now that LiDAR is being applied to the Amazon basin in a much greater extent, we have to figure out how to sort of analyze the LiDAR signal to find stuff. And it's harder than you'd think. So I did a little bit of work on this back in the day. Smurf was applied to bone mapping, which has been used in archaeology a little bit. So this is a new technique, which they're calling an elevation anomaly. The gist of it here is they calculated DTM at 1 meter using a tin, and then they calculated again at 4 meters using IDW, which is inverse distance weighting. So it's a different way of doing it. They resample that 4 meter one back down to 1 meter, and then they subtract the one from another. But all this really is just a local relief model. So I'm a little disappointed. I was a little disappointed in the paper. You can see what it looks like up here. Certainly that glyph structure shows up. They were comparing it to another kind of standard approach would be to use a hillshade to detect it. You can see that it also shows up in the hillshade. They try to make an argument that it's a little bit better. I don't think hillshades are that great, but there's a lot of other things, including some of the stuff that I did and 20 other ways of sort of doing this. So I was a little unimpressed, but it was a neat, it's a neat application. It's neat to see it applied to the Amazon basin. This is a new MLED survey tool. So I don't know that we're going to get one of these because I don't think that it does anything we can't already do. But it's a smaller RTK GPS portable unit to take, ground control points when you're doing drone surveys and stuff like that. So you can take this thing out. It's a little bit lighter weight. Kind of looks neat. I joined the Commission on Mountain Cartography. I got to thinking as I posted this slide, like I don't think I ever heard back. So I guess I don't really know whether I'm a member now or not. But my application is pending.
I like their robot check. 2
Yeah.
+ 2.
Very sophisticated. This is a project that came out of a little slide that came out of some stuff that Gunjan and I were talking about. I don't know if you're going to talk about this a little bit.
No, not this week.
Okay, so Gunjan and I were chatting a little bit about the thermal maps, and I've got a slide of the different thermal maps. And basically the idea here is that Gunjan's experiment is about finding how well people can make judgments using these thermal maps, right? How fast and how accurate are they with them? And then how does that compare to their preferences, right? They say they like this better, but actually they're faster on this one or whatever. So he and I were chatting a little bit about that. And the peculiar result is that the reaction time on the maps that people like better is longer. So like the shaded versions of these things that look a little bit like people prefer them 2 to 1, and yet it takes people longer to make these judgments. So the question is why? The theory is that if the map is better, you should be able to make judgments faster, right? All things being equal. But as we're trying to kind of make sense of this result, I think that there's an argument to be made that there's more information content on the shaded relief one. We're actually adding a second layer, right? It's not just thermal, it's thermal plus LiDAR. So it makes sense that it takes them longer to process it because there's more information on the map. So one way of measuring how much information is on the map is by calculating, you can calculate that, right? So we want to be able to sort of have a way of assessing which map has more information. And I remember that there's this paper from 2007 called Measuring Visual Clutter. So this is a slightly different approach to the problem. We've got 2 maps. Which one is more cluttered, right? Which one, is there a way to numerically quantify map design, right? Like, which is a better set? So that's what they were after here. They have a couple of different ways of doing it. The way that I was really interested in was this one, which is subband entropy. And the idea is you run this, in this case, in MATLAB, you run this MATLAB script, and it comes back with a number and says your map subband entropy score is 4.23, right? And then you run it on a different one that's the same area, but mapped differently, and that one is 3.1. So so it helps you quantify the stuff, and there are some other metrics, and Gunjan might dig into those a little bit. Because I had used this, I knew about this from some work that I had done a long time ago. I had the MATLAB code sitting around, and so I just wanted to kind of find it and run it real quick and just see if it seemed to make sense with Gunjan's data. So these are two examples of two different thermal maps of the same area. This one is Iron Bow. This one is Esri's temperature map, which we all find visually disgusting. It is the lowest ranked in terms of preference. Be interesting to see, does anybody rate it higher? Like, what's the highest individual rank? Was anybody like,
Yeah, somebody ranked it.
somebody makes it their highest? See, that's interesting, right? Like,
Yeah, but like I remember one person who was who ranked Israel as first, but when I was comparing it with I was comparing it with like results from like other users, that person's like preferences was kind of reversed. Like she put Israel as first, maybe Viridis second, and Iron and Darbo and the last like fourth or fifth. So I think that person has like a different color preferences. So,
okay. Do you think there's a chance that they thought 5 was better, like that their ranking system was different? That,
I
like,
actually asked
okay.
like why you have chosen this one. Like she was saying that, oh, I love this color.
Okay.
So
All right. Good
like
to know.
I don't think like that was based on like thermal map visualization, or
They
it
just found
was
the
more
colors.
about the colors.
That's great. So there's a lot of idiosyncratic thoughts about these maps. So that's interesting. Anyway, most people tend to prefer this one. Most people tend to not like that one as much. And the question is, can we quantitatively capture that? And can subband entropy as a metric do it? So these are the results. It's super easy to run it. Let me go back one slide here. It's super easy to run it. So you just say like, get clutter SE for subband entropy, and then you throw it your JPEG, and then it comes back and says that's your score, right? So I just did that with 10 of these, shaded and unshaded, Iron Bow through Esri temp. And these are the results down here. So the more subband entropy, the more clutter, right? But you could also think of it as the more information, which is a bit two-handed here. But so one of the things that you notice is that on all of these, the shaded has more subband entropy than the unshaded, right? Like that's consistent. Every single one of these has that. That makes sense, right? We're adding an extra layer. We're adding this LiDAR-derived DSM shading. It makes sense that the quantities would reflect that. And then they also go, so I also have these sorted left to right. I don't know, I mean, this I think doesn't match up as evenly with like the preferences that you saw, right? Iron Bow is best, Esri temp is worst. So it does sort of capture, there's a lot more going on in here than there is over there, I think. This one that I picked, is that unshaded? Unshaded, right? The Esri temp?
Yeah, non-shaded. No, this is the
Kind of hard to tell.
this is
Maybe
the
it
shaded
is.
one.
Yeah. Okay. Good question, Greg.
Yeah, so for the images on there, which one is which again? The
This is Iron Bow.
Iron Bow.
That's the Esri temp.
I feel like the Iron Bow is a little bit better because it's not as eye hurting as the Esri tip, in my opinion,
Yeah,
because of the colors, I'm guessing.
right. Yeah, and I think that's the sensibility of most people, that this one is just not aesthetically pleasing.
Yeah.
And so that is sort of reflected in the subband entropy score. So you can see that the Esri temp score is higher than the Iron Bow score. But you can kind of see that we're sort of talking out of both sides of our mouths here. That, like, on the one hand, we're saying like, oh, it's an information thing, and so that's why. But then we're also saying like, but it also captures this like aesthetically displeasing. So I don't know how we're going to spin that exactly, but those are the results, and
Like I think like for Iron Bow, this result supports, but for Esri it gets a little bit complicated because like, okay, so Esri is the most cluttered one, and people also, it's also the least preferred,
right.
but in terms of accuracy and response time, it actually ranks higher.
Yeah. And people prefer, so they prefer Esri temp, but they also prefer shading. So that's, we're sort of, it's, I think it's worth mentioning. It's a little complex, and maybe this doesn't capture what we wanted to capture, but there's certainly a pattern here, right? Like it's, I think I think, it's interesting too that Viridis is the second. And you can also look at sort of the differences between, like the relative difference between Esri temp for shaded versus unshaded is much smaller than iron bow, where the differences between shading and unshading. So anyway, interesting stuff. The last big thing that I had time to work on this week was the Esri deep learning stuff. So the reason I wanted to do this was Sam Karani did his master's thesis work on tornado damage assessment. So we flew a drone, captured the tornado track, and then the question was, how well can deep learning identify damage in those photos? At the time that Sam did it, that deep learning packages had really kind of just been folded into Esri. And so I was trying to get our Pro 3 installed with the brand new deep learning packages for 3. I really wanted to get to uninstall the 2.9 completely, because those two things are sort of barely held together anyway. So I wanted to do a complete uninstall and then a complete install with the 3.0 installer and not 2.3 and then an upgrade, which probably would have been fine. But anyway, I did eventually find the 3.0 installer on ArcGIS Online. So you can, if you go to that, then that's hooked up to your Virginia Tech account, and then that gives you the download option for that. So that worked out fine. I went through the tutorial. These are all linked, by the way, on the wiki. So I got you guys both access to the Slack. So
Just got that, yep.
So Google Drive is one thing that we need to get you hooked up to, and then the GitHub is the other one. And Chris, we got you hooked up to that already this week. So in the wiki, there's a tutorial that Shashank found in the summertime for classifying palm trees, which is a really good deep learning tutorial. So I went through that. I had a lot of weird crashing. Every time I would try to use this little toolbar at the top. You work for Esri. Did you have any complaints about that?
From what I remember, yes. I don't know if it was specifically associated with the deep learning things. I think it mostly just had to do with overrunning the software with a crap ton of data, which I guess with deep learning can easily happen.
Yeah, I thought at first I thought it was the deep learning thing, and then lately I feel like it's just this.
Just the diagnosed version.
Just that search box in the upper. Like every time I would try to use that, not every time, a third of the time it would just crash out. Whereas if I go through like the analysis and tools and
I think if I remember correctly too, that toolbox tool has been recently added, maybe like 2.9.3 sort of thing. So like there still could be some bugs associated with it.
In the end, though, I did get it working. It worked fine. I'm in the process of trying to get Sam's data rerun. I just want to do that before we submit the article for publication, just to make sure that everything's still working. So
I had a question about this, like the results we get are not very good, like even from the palm tree detection thing. Is there a way we could like add in a DEM data set? And
so that's what Sam did, right? So Sam's thesis was about how can we augment the RGB imagery with the LiDAR data or the point cloud data that we're getting at the same time. What he found was that most of the job can be done with the RGB imagery. So, and you do get a bump in accuracy by adding the DSM as a layer in the deep learning process. It's significant, like it's worth doing. But if you just ran it on imagery, you get a pretty good result. So, but yeah, these are terrible.
will it change if we are looking at vegetation instead of tuning to data? I don't know how that data look, but
I think it would make a difference based on the signature of the thing you're looking for, right? So if you had like a DSM associated with that, that would be a lot easier, because a palm tree, there's a study that came out of Santa Barbara actually, where they were like looking at like hyperspectral imagery plus LiDAR data. And what they found is that the hyperspectral imagery can detect trees pretty well, but for image classification, LiDAR didn't really help you distinguish between an oak and a maple that much. And again, this is like 12 years ago, so LiDAR resolution is better, but it did help a lot for these really morphologically distinct trees. So like just telling the difference between a palm tree and a maple tree that worked really well. Like LiDAR really did help with that because it's got a very strong spatial signature. But yeah, I think that this is uncovered territory. It's one of the things that I want to look at. We may get to this in analysis or we may not. We're definitely going to do some deep learning stuff in analysis this time around because the tools are so good. But there's Roanoke had asked me to take a look at their impervious surface classification. So
The city of Roanoke?
yeah, so the city, well, I guess it's technically the water, what is it called? Stormwater people. Because impervious surface, it's like a branch of the government around. But the idea here is that you pay a tax in lots of municipalities based on how much impervious surface you have on your property. More impervious surface, the more tax you pay. The reason is you're putting extra stress on the stormwater system. So they have to quantify how much impervious surface each parcel has. Like you've got this many square meters of impervious surface. And so you pay that tax. They've been doing it all manually. Like having a person for 3 months sit down and like look over aerial imagery for the whole city and add on, which is obviously super time consuming. It would be a really neat thing, a neat project to use their past data as training data, pipe it through this. And then one of the things that you get is a confidence. So like, we think this is a palm tree. Here's how confident we are though, and it can be high or it can be low. And so you could use that to flag new pixels in the data set and then sort them essentially by, confidence intervals and start with, whichever way you want to do it, start with highs or the lows and then start checking it, right? And so then then a human's job is like your job, Chris, which is to go back and review the automatic classification and then make adjustments as you go. Anyway. So I still have all that Roanoke impervious surface data, so it would be kind of a fun thing to do. And then this is the last of it. Lots of little things. So I just kind of grouped them all together. I've been working on the RAWS X-Ways stuff, which is a SLAM algorithm to take raw LiDAR instruments and turn them into a point cloud. The company that's behind this is French. They're super nice. It's a startup. I like email their, I don't even know if he's the CEO. I think he is. It's a small company. It's not a big one. It's like 10 people. Anyway, I came to find out that the Windows subsystem for Linux, which is a way to run Linux on Windows, that's more or less pretty seamless. Have you guys done this? So it's really handy. You can drop into Unix. Open a little command prompt. You have to install it, but it's a super easy install. There's a wiki page on this on the GitHub if you're interested in that. But for lots of people who use Linux to do work, it's nice to have access to all those Linux-based tools right at your fingertips. And I don't know if this will work. No. So Windows 11 integrated a really nice graphical backend as well. So this Windows 10 had support to do it, but you kind of had to shoehorn the stuff in there a little bit. And they've kind of like made that really hard, but with Windows 11, like you can run graphical stuff and do whatever you want. So I was trying to run ROS, the robot operating system, via Windows subsystem for Linux, and everything that I've tried to run on Windows subsystem for Linux has worked great. They have this little like licensing thing because they're trying to make this a product that they sell. ROS is free and open source, so they're trying to kind of like half protect their stuff. And anyway, for whatever reason, their little license application thing doesn't really work very well for WSL. I don't know why. The build stuff was a lot of hit and miss. We met on Wednesday and went through a bunch of new stuff. I found out that shutting down for Sept doesn't improve the frame grab. So we're both using the system to try to like get XY coordinates of who's moving through the system. And at the same time, grabbing all of that LiDAR data and logging it. And so Blickfeld thought maybe doing both of those together is just too taxing on the system. So I tried to shut down the one and use the other one. That didn't improve things. During our meeting, you had the idea of like, well, maybe all of the grabbing of the frames is messing up the clocks. So we shut down the grabbing of the frames. So nothing was happening other than just the clock. And we still think we saw clock drift over the course of even just a couple of minutes. So pretty strange. Some progress getting the firewall set up to block the external access to Sept. One of the engineers from Blickfeld sent me a link to Stack Overflow that I think got us part of the way there. We were supposed to meet with Blickfeld, so I had it on that, but that meeting got canceled. And I've got some plans to try to test the frame grab thing over the weekend. I'm going to write a little function that logs the time, makes the request for the frame, which will also include a timestamp, and then logs the time again. So then I can compare the time for all 11 sensors on my system clock. I can compare the timestamp that we're getting from the units themselves, and then I can look at the timestamp for when the operation finished. So we can start to see where like if we find that like my timestamps are all perfectly aligned to within like 1 millisecond, but then we find that the other ones are still, then we know that it's not my problem, right? The system, it's not my polling that's going wrong. So just an idea that I had. Lindsay and I include the hexing. I'm sure you'll talk about that a little bit. That was a good time. I'm trying to get the LiDAR classification stuff off the ground. So Chris and I met earlier in the week and got him started on that. So that's good news. I emailed Todd Ogle, who's the VR expert over at the library. I've got a project going on with him that we're trying to find somebody that's got like both VR experience and a lot of coding experience working with VR. And if we're lucky, a little bit of LiDAR experience. That's pretty tough. So if we can just get the VR component, I'll be happy. I can fill in the LiDAR part, but they're having trouble finding somebody. And then Jim's paper is ready to submit. Jim Young graduated about a year ago. So he did a paper on like LiDAR identification and landslides. He's had a lot of life going on since then. And so we wrote the thesis kind of ready to be published, but we never quite got it out the door. So I'm kind of making a big push to get that out the door. I think it's ready. So I'm hoping this weekend that'll get submitted for publication. I sent it to Jim earlier in the week and he sent me back a picture of his brand new baby. So he just had a baby on the 24th of August, so like about a week ago. So we're really excited. I was really excited for that. Goals for next week. So it's one of the things that we do is try to set goals for ourselves for the next week. These should be ideally achievable things that you will actually succeed on. Last week, I think I made the mistake of sort of adding goals in there that were sort of broader goals. So some of these I didn't make because I wasn't really sort of like, this is what I'm planning to do next week. So try to make goals that you will accomplish for next week. And then at these meetings, we can review how well we did. And ideally, you want all of these things to be green, or at least most of them to be green. I do green, some other people do other things. But so I did get good progress on the one with Jim. I forgot to get the meeting. Well, we tried sort of to get the meeting scheduled and we just ran into some trouble with scheduling. So before we wrap up completely today, maybe we'll try to find a time for that. I got some one-on-one meetings scheduled, but not everyone. So that's another thing that I need to fill in. I did get Chris started on the LiDAR classification and I got you guys started on the build stuff. So that was pretty good. We didn't do a FLIR flight anywhere last week, but I think that was more of like I don't think I intended to do it this week. I think I intended to do it soon. And then obviously that last one is a big year goal. So planning to submit Jim's paper, start prepping Sam's paper on the deep learning tornado stuff, try to get that out the door in a week if I'm lucky. Schedule all the one-on-ones, get a meeting scheduled for GE, and then hopefully try to fly a FLIR flight, but maybe the week after. So giving myself a little wiggle room there. That's it for me. Who's up next? Lindsay? All right, fantastic. Let's see if everything has gone. Well, it's right the other way.
Did you start recording?
I did, I think.
Yeah, I just.
Oh,
And then. That's, okay, there we go.
Just a short one from me. Yeah, so went to the drone park with Dr. Pingle on Tuesday. We were able to fly the Hexoon. I had one minor crash, but everything was okay. Didn't stick the landing,
That was totally my fault, by the way.
but all unharmed. The drone was fine. We were unable to fly the Mavic, unfortunately. Just when we went to go try and fly it, it said that it was in a no-fly zone. So that's what I was trying to do some research on later this week. It seems like geofencing is an answer that I think I want to try and do that. But when we were trying to look for the flight controller serial number, it listed as not applicable.
Mhm.
So I couldn't figure out an exact reason why that would be happening. A lot of the things that I said to basically take it into a shop and have it fixed. But another thing could be that it's just a bad cable or the firmware needs updated on the drone. So I was gonna check on that next week.
You should be able to do a fair bit of that, like in the lab, like you won't be able to like tackle the no-fly zone exactly until you're out there, but you can also, you know, get the Mavic out here and you can start working on it in a more comfortable place than the middle of a drone cage.
Yeah. So yeah. And then I was looking into the optimal battery charge for the Mavic. It was very broad range that I found, just anywhere from 25 to 62%. But I also read that it has an automatically time to discharge setting, and that kicks in after about 10 days of not being used.
That's awesome. I had no idea.
We can set it to a shorter amount of time if we would like, but
No, that's great. So, so lots of batteries. So particularly these lithium batteries that we use, if you leave them fully charged, they will really take a hit.
Explode.
Not explode, but they will get puffy actually sometimes, and that's not good. But they definitely get damaged if we leave them around at a full charge. I had no idea that it would like automatically initiate a. So the batteries that we use for the Hexoon are these like, they're not very smart. They're just like a brick and they've got a connector. But the DJI batteries are sort of like smart batteries. They've got electronics that control them. So I had no idea there was this feature. That's nice. Now I worry less that we've damaged our batteries by not doing anything with that DJI drone for so long.
yeah. And then my goals for next week was to figure out why we can't find the serial number for the flight controller and hopefully fly the Mavic too. And I forgot to put it up there, but actually do the drone park orientation.
So for those of you who want to join in, feel free to get in contact with Lindsay, and I think she's going to be the point person on getting that stuff restarted. Drone park. Everybody that wants to fly should do that. It'd be great if we fly these things every week, and it doesn't have to be at the drone cage all the time, but we'll do that for the first few weeks while everybody gets comfortable flying, and then we can start flying at more fun locations.
Yep. I was looking to go to the drone park on Thursday morning if anybody would like to join.
Gunjan, it's been a while since you've flown. I guess you got a busy semester. You got to write your thesis.
the morning is not possible for me.
Out of curiosity, where can't we fly?
Well,
It's easier to say where we can. I didn't know which would be easier.
So, the rules of Virginia Tech are you can't basically fly on any Virginia Tech property without some pretty explicit permissions.
Okay,
There's a whole process for getting those permissions, so we could fly. But all the same rules about sort of where you can fly from like an FAA perspective apply. So you can't fly over people.
Or you can't fly near some miles away from it near an airport?
So there's airspace, yeah, different airports have different airspace concerns. Ours doesn't, but we do have air traffic. And the reason the drone cage comes up is we're sort of in the runway path of the Blacksburg Airport. And so it doesn't know the difference. Like, we're inside a net, so we're not going to be hitting any aircraft. That's the whole purpose of it. But it is literally like 10 meters inside a no-fly zone. It's super annoying. I'm sure they find that. I wonder, like, I know DJI does update their databases, and it would be nice if someone would just carve out a little drone cage.
Sometimes it's like you have to just update the software because they are like updating that every time. So if you're using the older version, they just show you some error, a lot of things. We also had the issues in the drone park. Then we had to reinstall the software and do this. So I think it will be okay if you update your software and see how it goes.
Cool. All right, thanks.
Who's next?
Am I next?
Sure.
Let's go.
Before we leave today, we should charge all of the Mavic batteries so that they're all good to go.
What, was I going today or?
No, you don't have to. We're just passing it along. Who's over next? Is it Gunjan then? Next?
Yeah.
You want to give us a quick verbal update of how things are going for that
Yes,
presentation?
sure. I found that with the LiDAR classification, I found that it was easier, that the buildings are the easiest than the vegetation, aka trees, because trees can have, light can pierce through trees very easily and hit the ground. So it's very hard for me to classify trees, but it's easier to classify buildings because obviously they're opaque, and even the buildings that are what's the word again? Rectangular or have straight lines makes it easier for me to classify buildings. Also easy to classify ground as well. I know it's a little sketchy, but
No, that's good. It occurred to me looking at that at the point cloud that we may want to have a different classification for cars because there are a lot of cars and they're kind of none of the above.
Yeah, I've noticed a lot of cars there as well.
So we may want to come up with a classification, but if you just kind of want to keep going on the buildings for now, I think that's great.
Buildings or ground, if there's ground that needs to be reclassified.
Okay, yeah, let's start there.
Yeah. Because I noticed the few point clouds that look like cars as well.
Yeah. So maybe before you leave today, I can just take a quick look at the stuff you've done, just because we're heading into the weekend, a long weekend, and if you're going to be doing work, then.
Oh, I forgot it was Labor Day week.
Yeah. Ready?
What is the shortcut?
F5.
Oh, no, I'm just asking for the shortcut for hiding this one.
Control Alt Shift H.
Lots of them. Sorry. So this week was mostly I was running my thesis analysis. So yeah, let's get started on that. So Dr. Pingle showed some, like, with subband entropy. He showed some. He was also talking about some ranking things, and we were discussing this one. So this is basically a line chart, but as we are working with rank data, so so this is called a bump chart, where, like, for different variables you can show the ranking changes. So in here what I did was, like, we have a preference ranking, but for the convenience of the chart, we converted that ranking to score. So if somebody is ranking first and we have like five of them, so like the first one gets 5 and the last one gets 1. So and I assigned this scores for each ranking and then created this chart, and this was for preference, accuracy, and response time. I looked into some literature to validate whether I'm doing it correctly or not, and I saw that, like, many of the psychological studies and also in some of the business studies, they are using this just for easier interpretation.
Okay.
So I think, and I think, like, I reviewed like 10, 12 articles, and like I saw like in 60% of them, they were more likely like an executive report, like a gray literature kind of thing. But in academic papers, they also use this kind of thing just for easy interpretation. And I think like if I'm presenting in the conference, this will be an easier way to interpret like what's going on in here.
Yeah.
So so as you can see here that the iron bow color map in the preference, it ranks second, but in terms of accuracy and response time, it actually ranks first. Like, and it's for all the 3 tasks. So like in the previous week, I looked into like individual tasks, but so Dr. Mingal and I were discussing last week, and I also saw like some literature there, like which were not only discussing about like individual tasks, but also like compiling them all together, because our hypothesis was kind of like which color map works best, which shading works best, or which resolution works best for like visualizing thermal visualization. So yeah, so I just accumulated all of them and then created this one. So and our first hypothesis was like iron bow or turbo may work the best. So as we can see here that it may be like in terms of preference it's second, but like in terms of accuracy and response time, iron bow is performing really well. And turbo is ranking the first, but in terms of accuracy and response time, it's not working that well. And actually, in terms of response time, it actually ranks last. So it's so yeah, but also on the other hand, turbo is, I think, still the most widely used for visualizing temperature, because like I had some participants who were from engineering departments and also from biological sciences who also worked with temperature data, and most of them were like, okay, yeah, turbo, I know that, because most of them were working with turbo and they haven't even considered the other color maps that I used here. So yeah.
So a couple of really nice things about this. One is like it's really easy to make some direct comparisons. So like iron bow outperforms Esri temp on every category, right? So you know, like that's a pretty convincing argument that between those two,
yes,
that's the one you want, right? There's almost no reason to use it.
Yeah,
it's great. A couple of suggestions. One, I think this looked great. Like I'm so impressed that you got this by today. We had just chatted about this yesterday.
Yeah.
So nice work on the turnaround. You'll want to change it so that 1 is on top.
Okay.
And that ranks. So what you want to do is reverse the axis,
Okay.
so that 1 is still the best and 5 is the worst, but you want 1 at the top and 5 at the bottom. So rankings are just kind of require some special handling.
I mean, you do say score though, so then I would change color map ranking distribution, so then that it's clear there.
Oh,
Yep.
okay.
And
So I was
then,
gonna say, because score, this makes sense of 5 being the most points
Yes.
is the best, but if you're gonna change it to a ranking, then flip the axis and then change rank or score to rank.
and then try to eliminate the 0 and the 6 from the thing, so that it's nice and clear.
Yeah, this was just like a quick thing to do.
Totally.
Like,
No,
yeah.
sorry. Yeah, I'm
It's like-
pointing them out so you know.
No.
I'm impressed that this is here, and it turned out better than I. Did you do it in Excel?
Yes.
Okay, that's an easy.
That's a easy thing to do. Yeah, but because I had this, the reason I put the score, because like if I want to make the graph instantly, that was the like the easiest thing to do.
Totally.
And I also looked into some literature and like, okay, so my decision is validated right now. But yeah, I can do that as well. So yeah. So this came out well for the color map. And
One other little piece of advice, so you're writing your thesis, but you're also going to have to give a thesis presentation, right? Your thesis defense. Start that thesis defense file, take your proposal, copy it, make that your thesis defense, and then make sure that when you get this figure done, you add it in there right away, right? Because you're going to build, you don't want to build your thesis defense PowerPoint in November. You want to build it as you're writing it, so it's all in place.
Yeah, I actually like copied all my analysis slides, like last week I also presented some analysis. So I'm just copying those slides and putting it in a separate PowerPoint file. And it's also kind of like a summary of what I
Yeah.
did. Because if I look into the Excel file, the Python codes and other things, it just gets messed up. So I'm just putting it all together so that it's easier for me to understand. So yeah, this is for the color maps, and for the shading, people definitely prefer, I think if I remember the figure correctly, the 67% people prefer the shaded maps, and in terms of accuracy, that's good as well. But in terms of response time, the unshaded maps are doing better. So I think from this we can we can add some statements from the subband entropy score, because it shows that the shaded maps are more cluttered. So maybe that's the reason that the response time is higher. But as it's providing more information, the accuracy is higher.
Correct.
So
Yeah, I think that's a good story.
Yeah.
That makes sense to me. I think people are gonna buy that. Yeah.
So, but in terms of like, I think for the iron bow, the subband entropy score may be a very good statement, but I'm still not sure how to interpret the Esri 10, but I think we can figure it out. But at least for the iron bow, we can make that statement. But for the shaded one, it works really well because we have a strong evidence for that. Okay, and for the source, it's not an interesting graph, because in both cases the drone maps work well, like in terms of response time and accuracy. But like when we were looking into like individual tasks, the scenario was a little bit different. I presented last week, but overall, the drone maps works better in terms of response time.
And what happened was, I think on this one, I would probably break it down by task,
Yeah.
because I think that's more informative.
Yes.
This
one doesn't work that well.
Right. Yeah.
Okay, so the next thing was I ran some repeated measures ANOVA. So the reason of doing repeated measures ANOVA is like, so I have like 5 color maps, 2 shading conditions and 2 sources. So I needed to see like which combinations are like performing well in terms of like, and compare it with each other, and I need to do them together, like not like seeing one by one. And I think there were like 21 combinations of like, if I consider all of them together, like source, color map, shading. So I considered all of them, and I did it in Jump. Jump is a statistical software, and if any of you are taking the statistics for research 1 or 2, they mostly use the Jump software in there. So it's so I used a subplot design. So within a subplot design, what I did was like I nested. So I had this 2 main variable that was like source and the task, and I nested the color map and the shading and randomized them, because source and task means I think Dr. you remember that we created a column with source task.
Mhm.
So that's why we came up with like city A/B comparison task, city profile task, so things like that. So I nested them with color map and shading, and then I came up with all the combinations. So this graphs actually show the least square means of accuracy with different color map and shading condition for the task. So you can see, so we are still not sure whether we are going to use it or not, but it kind of gives like, so for the accuracy, the higher the better. So I think, so maybe for the city rotation task, we can see that the unshaded Esri temp has the highest least square mean. So that means this one is performing better than compared to the other ones in terms of accuracy. And maybe for the drone A/B task, the Viridis is working better than most of them. So this kind of gives comparison among the combinations, all the possible combinations that we have. So we still need to figure out like how we are going to use it, or whether we are going to use it or not in our analysis. So I have the same thing for the response time z-score as well. So you can see the variations in there. So like in the last slide, as you can see that the Viridis unshaded Viridis for the drone A/B task has the highest accuracy, but in terms of like response time, it has the least. So it has a it also has the least z-score. That means it also took like less response time, so it performed well in terms of that. So yeah, we dig into that a little bit more. So yeah, so this was it for like showing it for the lab presentations. So the goals for the next week is I need to figure out how to make ellipse plot for accuracy versus log response time. So it can also Dr. Pingle used one in one of his studies as well in the ellipse plot. So where it shows the position of the combinations within the graph, and it kind of gives you like visually gives you like a clear indication of like which one is performing better. So it kind of like summarizes the whole thing. So I need to figure out how that works. And I sent out an email to my thesis committee members to share the preliminary analysis results yesterday. So I'm hoping to hear back from them. So maybe this week or sorry, later next week or earlier the next week. So yeah, and also start writing the methods section. Yeah, that's it.
One last piece of advice is start that method section today. Like, always easy to put off the writing. So even if you just do a paragraph, just get the ball rolling so you're started. Right? The hardest part is getting going. Good job. That was great. Lots of stuff in there. You two are not presenting?
I think that was presentation. If you want to give a brief update of what you did.
I can just talk about it really quickly.
Sure.
Yeah, I'm working on stacking the images and still kind of going through that and figuring out how to make an SPF. So I figured out that I was having issues with Anaconda because it was no longer installed on my computer, so I had to reinstall it. So that helped with the first part. And then I installed Spider as well. I installed the new package, and now I'm working on installing X-Ray, but I'm having some issues installing X-Ray. So I need to figure out what's going on there.
Pretty normal stuff. Thanks. That was these guys will be sort of tackling a lot of individual projects as we go. So getting the Python stuff nailed down is always good. Can you pass over the sure. One of the things, it didn't make it into my lab report either, but one of the things that we found as we were doing it is a neat package called XIO array. Is that right?
I think it's just X-Ray.
No, but there's another one.
Oh, it's not Rasterio.
Mysterio. It's like an X-ray plus Rasterio thing. I think I added it already to Python here. So this is the thing we're going to add you both to. This is our lab wiki, tons of stuff in there. So it's a good resource as you're learning stuff. Rio X-ray. So what Rio X-ray can do, this is sort of like built on top of X-ray. So X-ray is intended to work with these like temporal data sets. NetCDF is like a stack of, it could be a lot of things, but we're going to use it as a stack of rasters. And so this will handle, blends that plus Rasterio. And Rasterio is a package that we use all the time for raster data. It's built on top of GDAL. And so this is a neat, I didn't even know about this. This just kind of like puts those two things together. It sounds like there was like a Rasterio reader built inside X-Array, and then it got sort of like ported out to this project. We got a deprecation warning when we were starting to play around with it.
I forgot to share one Python package that was written by one of my friends. He's doing a PhD. He's doing PhD in St. Louis University in Missouri.
Yeah.
So the name is Raster for ML. ML, machine learning. Yeah, ML. Yeah. So this one. So this one actually like so in the documentation you can see that it can stack the layers quite easily. I haven't really tried it, and it also like has this vegetation in this. It's like 350 plus indices it has, and I think maybe he did it for his PhD project, so it kind of like makes it easier to run this sort of thing.
Okay. For those of you in analysis, there's your creating an
I
environment.
remember that.
Okay. Cool, yeah, thanks for sharing. We should add this to the Python list. All right, thanks, everybody. We'll call it a day there then, and we'll see you back next week. Have a nice long weekend. Some of you I wanted to chat with a little bit about getting a Google Earth engine date figured out. Chris, I want to see. Well, it sounds like you're doing pretty well. I guess we're set. I just want to make sure that you're saving your work
Yeah,
before you leave, because you can kind of do your work in Cloud Compare, but if you don't save it, then
then, oh no.
and we need to charge batteries, which I guess you can just do. They're all sort of there.
Alright.
And we need to get you guys set up with Google Earth or with Google Drive and GitHub. So let's start with that GitHub first.
I was gonna say, I unfortunately don't have a computer, but I do have.
That's okay. Do you have so you guys have GitHub accounts already?
No, I'm making.
I do.
Okay, you can make one and we'll get Fatima added. Collaborators.
Do you know if like tech has a partnership? Because it sounded like start a free trial.
It's free, yeah.
Oh, wait, this is for enterprise.
Yeah.
Okay, that makes.
If it weren't free, we'd switch to something else that was free.
Fatima Pugh,
How do you spell the last name?
PIU. Yeah.
Okay. So you get the invite, and then I'll pull up in Google Drive as well, so that's easy to do. Oh, and we gotta stop our meeting, don't we? Did I stop the meeting? No, I did not. I'm sharing.